So DNS is responsible for translating the web address you input in your address field into numeric values, into numbers that your PC can understand. Now remember that there are different kinds of there are different number systems, and we said that the computer understands binary. Mostly what you will see is actually going to be in decimal, because humans understand decimal more than binary, and decimal is like your 1 2 3 4 5 6 7 8 9 10, like that. That particular web address action represented in decimals. So we are going to explain this in more details in our subsequent classes, but know that this is an example of a protocol that's used in networking. There's another one called DHCP. So this one is responsible for each devices on the network usually have an ID, and this ID is called an IP address. I think I should call it an address now, not an ID, because that is exactly what it is. So the IP address is how the computer is located on the network. So when I'm trying to communicate with somebody else on the networks, let's say I'm on the same network as Mr. John, Mr. Philip, Mrs. Choma, and then we are like 10 on the network. Then I want to communicate specifically to Mr. John, right? Mr. John has an address called the IP address. You understand? So when I send my message, I say my message is directed to Mr. John's IP address. That way, the message is delivered to him specifically. So the DHCP is the protocol that's responsible for assigning addresses to these devices on the network, and oftentimes it does it dynamically. That's to say the IP address can change. It is given to those people as needed. When the person leaves the network for a particular period of time, the IP address is withdrawn and it can be given to another person, like that. So there's a whole lot of process under it as well. We are going to be discussing that in subsequent classes, like we said. But yeah, this is how protocols work. Based on this, now different devices are able to communicate seamlessly and with ease, despite the fact that they might be made by different manufacturers and different companies with different hardware technologies running on them. So because of this, now a computer can connect to an iPad, and an iPad can connect to a mobile phone, as long as they are designed to communicate in that particular manner. So, and we talked about routers and switches and cables. These are examples of devices that you find on the network, and the router is typically that device that stands on the gateway. It represents an officer who does exchange between two parties, right? So if you're trying to communicate with another person on a different network, you technically will use a router for that. If you're trying to access your internet, most of us are familiar with routers when we talk about internet connectivity, right? It does that, yes, but you're going to be learning about routers beyond the router that you use with your MTN and your Glo, your normal service providers. So your router is going to stand as the gate between your network and another network. So if there is one network here and there's another network here, and then there is need for communication between those two networks, there's usually going to be a router in between to manage the traffic between these two networks. There's a whole lot of things that you can do with a router, and again we'll talk about that in other classes. Then we have switches, and switches are how those different devices can connect together on the network. Remember when we were talking about the ring technology, we said a switch is typically the device that's at the center. When we were talking about the start topology, we said it's typically the device at the center where all the devices are connected. So you can multiplex messages. You can send message and redirect messages appropriately to the right recipient from a particular sender. Then we also talked about cables. The cables used in networking are usually not the type of cable that you use to wire your house. They are specialized cables for networking, I don't know if I have a picture of that here. Let's see. Okay, I don't. Alright, but yeah, we're going to see them, the different kinds of cable, and why we use mostly Cat5 and Cat6 cables for internet communication. But yes, cables can also be used for networking, but then there's also wireless. Remember I mentioned that earlier. When you're using an access point, we'll be explaining that that technology for wireless communication later, right? So these are example of devices that you can find on the network, right? And technically, sometimes maybe you're trying to connect to a computer. You're trying to connect a computer to the network, and you're not able to connect. Some things you can look at is to check for if the router is on, or your means of internet connectivity could be a modem router. Your MTN router, ISP provided router are not the only way to connect to the internet, right? There's so many other ways, right? Yes, some people, I don't know if any of you had experience using that portable modem we used to use then. So, right, yeah, and then there are some times that you have to like open your command line and try to troubleshoot the network by yourself. So that's why you see use commands like ping and ipconfig to diagnose problems. Sometimes you need to like restart, and restarting also fix the problem. So it varies. These are basic troubleshooting tips for networking. So again, if you're able to just know what it is and what we are talking about right now, you're good to go. And the subsequent classes will explain details. Then it will not be like you're experiencing this concept new, because trust me, it can be overwhelming for some people. So right now we talked about IP addresses. There are different types of IP addresses. It can be IPv4 and IPv6. So IPv4 addresses are the normal one you are going to be seeing frequently, right? And it's just a typical example is you see 192.168.0.0.1, for example. But then when you're talking about IPv6 addresses, they are usually larger and longer, and the streams of hexadecimal bits, not just the decimals that I just used as an example. Virtual local area networks are examples of local area networks, which is a type of network. Yeah, this is just virtual, right? And it basically just means your one network, you're dividing it into some smaller networks so that you are able to manage the traffic better. So they are going to manage communication. An example is when you have 100 people in a room and you're trying to communicate, and everyone is trying to communicate in that room. It can get noisy, it can get messy, but imagine you separate those 100 people by some things that they have in common. Maybe like 100 of these, 10 of these 100 people are blacks, the other one are Caucasians, or maybe these other 10 are IT oriented, and these other ones are government oriented or politically oriented, or these other ones are just some common things that you have in between them. So by the time you group them, it's easy for them to communicate amongst themselves. And then when there is a need for all of them or one of them to communicate with one person on the outside, then they just use one particular gateway. So that way communication is organized, not very rowdy. So that's just an example where you can look at virtual local area networks. Just a segment of network, a smaller network, so that it can be easy to manage. While a VPN is a technology that allows you to communicate securely over the internet, so that other people are not, maybe like a criminal hacker is not able to listen to what you are what you are trying to communicate. This happened by encryption. We're going to explain in details what encryption means when we are doing networking, right? But it basically means even if the hacker is looking or trying to hack your communication, the hacker is not going to understand it, because everything is saying is going to be meaningless to it. So yes, that's another concept in networking that we'll be looking at. So yeah, configuring router and wireless access points. We're going to skip that for now. and troubleshooting also we are going to skip that for now.